area equals length times width. You're familiar with that. And the problem we are given is it says to find the length of a rectangle that has an area of 35 square feet and a width of 7 feet. So what we need to do is we need a formula that is going to equal length. So easy trick for this is to use a math sentence that you are familiar with. So I'm going to use a very simple one. I'm going to use 2 times 3 equals 6. Now back in grade school you remember learning family of facts. So if I want to know and solve for L, or solve for 2, I'm going to say that L would be equal to, and to get to the L, I would need to use my 3 and my 6. So the way I would do that is, my 6 is my area, and I'm going to divide that by my width. Now I have a function for solving for length. Now let's use it for the given problem. So find the length of a rectangle that has an area of 35 and the width of 7. So my answer would be that the length would be 5 feet. I'm going to do the same thing in example 2. This time I'm using temperature. They're going to give me a conversion formula that Celsius is equal to 5/9 the quantity of Fahrenheit minus 32. So we want to use that original formula, and this time we want to make sure that we can solve for Fahrenheit instead. So this time I'm going to use some things with balanced equations in order to solve for F. So first of all, I have that the distributor of fraction. So I'm going to get rid of that by multiplying both sides by its reciprocal. Once I do that, I get 9/5, my variable for Celsius, equals Fahrenheit minus 32. Now I can go ahead and get my variable that I want to solve for would be Fahrenheit, so I can isolate that by using balanced equation. I'm going to add the 32 onto both sides, and now I have a new formula that's going to be 9/5 Celsius plus 32 is equal to Fahrenheit. And now um, given information, I could go ahead and substitute that in. Example 3 is using simple interest formula. The simple interest formula is that interest equals principal times rate times time. We've used that already this year. Now what I want to do is, in this one, I want to find the interest rate. So I want to solve for R. In order to do that, I am going to need to isolate R. So when I'm looking, I'm going to rewrite this so it'll be a little bit easier. I'm going to write interest equals principal times rate times time. Now, principal and time are both being multiplied by rate, so I'm going to do the inverse operation, or I'm going to divide both sides, being a balanced equation, by principal times time. When I do that, I will get rate isolated, and rate equals interest over principal times time. Now I can go ahead and use the given information, and the given information is that my interest is $54. My principal, or the original investment, is 1,500, and the time is for 1 year. I can go ahead and simplify that, put that into a calculator. I get 0.036 0.36, and changing that into an interest rate would be 3.6%. Example 4 is going to be using the distance formula. Distance formula is originally what you have learned has been distance equals, oh no, look at P. Distance equals rate times time, and I'm going to change that because I want to be able to solve for time. So when I solve for time, I'm going to divide both sides by rate to isolate time. So now I have my new formula, time equals distance divided by rate. Now I'm going to plug it into the information I have in the story problem. I have that it traveled a distance of 310 million miles, and I have that the rate was 30,000. 30,000 miles per hour for the first one, 40,000 miles per hour for the next, and so on. So for each one of these, run out a little bit of room here. I'm going to show you the 30,000 one, and I think you can follow from there. I have 310,000, my distance. My pen will work here. And I'm going to divide that by the rate in the first one of 30,000. Put that into a calculator again, and I would end up with 10,300. My pen's not working again. 10,333. That would be in hours, and I could go ahead and convert that, and that would equal 431 days. Sorry, I'm writing with my finger at this point. Not a whole lot better than the pen. Let me make that a little clearer. Now, for each of the other given distances or the other given rates, I would still take the distance that was traveled, the 310 million miles, and I would go ahead and I would divide those by 30,000. I did just notice another mistake when I was writing with my pen here. I noticed that I had $310,000 there, or 310,000 miles, and I should have had 310 million miles. So that is what was plugged into the calculator. This was not what was written on the page. Okay, moving on to the next example, we're going to rewrite in a function form. So we've taken a whole bunch of formulas and rewritten them. Now we're going to rewrite some equations. To rewrite an equation in function form, it says so that y is a function of x. Function is another word for work. So the work of x is going to give us the result of y. So this time we want to isolate y. In this equation, I would need to use balanced equation to subtract 3x from both sides. I would then end up with y equals, I'm going to put my variable first, and I have a negative 3x, and then my constant term, positive 4. It's real important to write this in this form because this will come up again later. The next example is going to write it so that x is a function of y. Again, that means the work of y is going to give you the result of x. So this time we want to isolate our x. The first thing I will do is, using balanced equation, I will subtract y from both sides. That will give me my 3x, and again I'm going to write my variable first, negative y, positive 4. Now I need to get x by itself, so I'm going to divide both sides by 3, giving me x equals, and I can't do any reducing here, so I will just leave it in the form of negative y plus 4 divided by 3. Our final example is going to be talking about what we do once we get it into function form, and that means that we will put it into an input-output chart. I'm going to go ahead and I'm going to use our last equation. So let me go ahead and copy that. And see if I can paste it on the next page. And see if it'll let me, yep, let me move it. There we go. Alright, so the input-output means that I'm going to put in a value for, in this case, because x is going to be our output, because we're solving for x here, I'm going to give some values for y. So the inputs that I'm going to put in here, I'm going to put y equals negative 2, y equals negative 1, 0, 1, and 2. Now what I need to do is then substitute them into the equation. So for the first one, I'm going to do a negative negative y. So I would do a negative negative 2. And I'm going to do plus 4 divided by 3. So in this one I have a negative negative 2. So that would change to a positive 2. And plus 4. So I would have 6 over 3. And again, I can reduce that to 2. So when y is negative 2, x is going to be 2. Doing the same thing for the next one, I would have a negative negative 1 plus 4, they're running into each other there, divide by 3. I would get 1 plus 4, which would be 5. And this time I'm going to leave it as an improper fraction, 5/3. 0 would be an easy one. Doesn't matter if that's a negative y or not. I'm going to end up with just 4/3. Just the constant terms would remain. If I substitute in 1, I would have a negative 1 plus 4 divided by 3. I would have 3 over 3, which would simplify to 1. And I guess I don't have to do 2. 2's not in the book, but I have it written, so we'll go ahead and do it. So a negative 2 plus 4 divided by 3, I would get 2/3. And that's how we would use an input-output. You would input the value, that is the function, y is the function there. Then you would substitute it in, and you would get the outputs, which is what we solved over here. So we would be solving for the x value. And that concludes the lesson for 3.7.